Thank you all for coming for this panel. We are going to start now, a little bit late, for this civil-military UAS panel. I invite you to participate in this next 1.5 hours, 90 minutes, for the people who are already thinking in summertime. And I want to invite you on behalf of NATO and EDA to participate in this panel. And thank you to Expodronica and to the World ATM Congress to offer us this wonderful fora to share the ideas that we think in the military, civil-military coordination are necessary. We are going to see in this panel 3 main blocks. Block 1, the military perspective, is going to be like a strategic one. Then we will descend to the operational perspective a little bit down the scope. And then finally, the challenges from the industrial phase. What you will see in this 1.5 hours is from the highest airspace to the lowest airspace, the integration of this complete airspace in real time. And for this, we will use one of the main principal use of the air power. Centralized command, decentralized execution. And for my part, that's all. I want to now to give the floor to Christophe Vivier from the EDA, and then Michael Callender from NATO will start with the strategic ideas. Thank you.
Thank you very much, Arturo, and thank you again to Expodronica for organizing this session on civil-military coordination in the drone domain, and for inviting EDA to this session. Indeed, EDA is involved in a wide range of activities in this area of drones. Drones ranging from small tactical drones to large sophisticated systems offer indeed many civil and military applications, and they are indispensable in any EU-led mission or operation like IRINI mission, for instance. Therefore, it is important for EDA to drive European capability development in this domain, including, as said by Arturo, civil-military cooperation and related synergy. First, I would like to display a video highlighting EDA activities in this domain, and then I will highlight some key messages.
Military aviation is key for security and defense. Remotely piloted aircraft systems, or ARPAs, have demonstrated their importance in military and civil operations, particularly for surveillance and information gathering, border control, or disaster monitoring. In order to unlock their full potential, the European Defence Agency supports member states in the safe integration of military ARPAs in non-segregated airspace. A central task is to ensure coordination among all stakeholders to achieve interoperability and ensure the highest level of safety. For instance, the agency supports member states in defining the concept for air traffic integration of medium-altitude, long-endurance ARPAs. EDA, together with its member states, also tackles regulatory aspects through best practices for safety requirements on cross-border movement. In the technical domain, our mission is to support research, development, and standardization activities in autonomy and artificial intelligence for emergency situations. Remote pilot stations standardization for ARPAS operation into the European Air Traffic Management System, detect and avoid, and command and control data links. We also work on identifying the missing key technical enablers for airspace integration starting in 2025, and to ensure their availability using different implementation mechanisms and funding opportunities. Already in 2013, heads of state and government declared military Arpas a key capability priority. With the support of EDA, the European Air Forces are making good progress on the safe integration of large remotely piloted aircraft systems in non-segregated airspace. Civil operators will also benefit from their work.
So I would like now to highlight some topics addressed in this video. First, as said by Arturo, and I really would like to insist on that, and this is probably my most important message, civil-military collaboration and civil-military synergies is key at all levels, national level, EU level, and global level. This is, once again, paramount. This is key to first capitalize on the military experience and know-how in drones operations and drones-related technology. Also to identify and address potential impact of the integration of all types of civil drones in the airspace on security and defense, as well as to develop dual-use technologies leading to economy of scale. I would like also to say a few words regarding Arpas accommodation. I will not elaborate too much on that because you will see some presentation on that, but mail cross-border flights are possible today. Mail, medium altitude, long endurance, cross-border flights are possible today. This will be explained. And the accommodation shall be seen as a transition phase toward the full integration. We are also trying to harmonize the military and to make a convergence between the military regulations and civil regulation. Ideally, if you are integrating from the upfront all the military specificities in civil works, at the end of the day, everyone might use the same regulation, the same standard, the same technologies. Regarding research and development, as explained in the video, we are focusing on the use of artificial intelligence for full autonomy for emergency situation and standardization of remote pilot stations. I would like to highlight that these works carried out in a military context might benefit all drone stakeholders. And last but not least, we are also involved in the ongoing work regarding the development of a drone strategy 2.0 because, once again, now it has been fully understood that the military should be integrated from the outset, and we will integrate some civil-military aspects in this future strategy currently under development under the lead of the European Commission. This concludes my few words on this important topic, and obviously I will respond to the potential questions you might have. Many thanks.
Thank you, Christophe, for your nice presentation. I want to point out the main things is about this synergy and the civilian and military, which is paramount in all about. Now, Michael, from NATO, he will show you. Okay,
Thank you very much, Arturo. Thank you very much, Christophe. Great words. Again, I'm just going to build off what Christophe has said. What's paramount about how we get ARPAs integrated fully into airspace, non-segregated airspace, it's predicated on the relationship that we have, the confidence the civil community has with the military community and the military ability to meet standards of safety and standards of performance. This is key. How do we get that confidence built up is the question. That's the hard part. And so we do that a number of different ways. At the NATO level, we do that through the Aviation Committee. This is the highest level committee. It's a level 1 committee reporting directly to the North Atlantic Council on all things related to aviation, particularly that civil military aspect. We have 30 allies, a caucus of 30 allies agreeing to everything, or agreeing to the same principles, along with members of ICAO, EASA, FAA, Eurokai, IATA, DG Move, EDA, and Eurocontrol. You see on your seats a copy of a policy that caucus of 30 nations have come up with, which is the integration and the NATO policy of aircraft, unmanned aircraft systems. This is the mainstay of what we're trying to do in NATO. In addition to the work that we're doing at the policy level and the standards level, we're working very closely with EDA on the assessment for when it comes to either mail, ARPAs, or at the lower level in U-space, and making sure that those military requirements are supported by EDA within the EU context, but also looked at a global scale across all of the members of the alliance. Working with Eurocontrol with the redefining the guidelines for Global Hawk is also a key step in either getting at the high altitude or in the lower altitudes when it comes to security. And I would be remiss for any NATO response if we did not mention the NIASCOG. This is one of those beautiful acronyms that's NATO Eurocontrol, and it's called the NATO Eurocontrol ATM Security Coordinating Group. And it's within this group that we're looking at the risk assessment for not only mail and hail ARPAs, but the impact of small UAS within the broader ATM system. So as I said in the beginning, the point, as alluded to by Christophe, is how do we build that confidence within the civil community as to what NATO and the military and the other entities are doing for non-segregated or flight of ARPAs in non-segregated airspace. And we have created a new program. It's called the ARPA's Readiness Initiative, or the R2I. And the R2I is formed by the Joint Capability Group for UAS, which is looking at what it takes. And there's three different pillars: the operational requirements pillar, a coherence pillar, and an awareness pillar. And I think what's really important in order to facilitate that work isn't the operational requirements. That's being done by the military. At the strategic level, it's the training and education. It's the awareness of what those standards are and how those standards are moving forward. And here's the rationale. Right now in Europe, in the European context, there's about 60 mail assets across the NATO alliance. Mail assets today, but those are usually only usable within austere or non-national airspace environments. However, over the next decade, European allies are procuring 250 mail ARPAs. This is coming. We need to figure out a way to integrate those ARPAs into airspace safely and effectively. How do we do that? We do that through the application of common standards and through studies. One of those studies that NATO is supporting is a $250,000 industry-led study on the detect and avoid, on re-ratifying the detect and avoid standards that we currently have. It's NIAG Study 278, and this should be produced in December of 2022. And so with that, I know that nobody wants to hear NATO talk. What you'd rather hear is the military aspects in what that operational effort is. So I just want to say thank you to Expodronica for hosting us here. Thank you to EDA, and thank you for Arturo for kindly moderating this session. So over to you, Arturo. Thank you.
Thank you, Michael. Just as a reminder, as Michael was putting emphasis on it, we want to get this confidence built up on safety and efficient coordination between the highest airspace and the lowest airspace. So now we have a couple of minutes, because we are a little bit late, for questions. Do you have any question? No questions? So then we finish up with the block one, which was the strategic ideas and the strategic vision of the Arpas and civil and military cooperation. Now we're going one step down. We are going to see three speakers, one from NATO, itself, and then two nationals, one from Spain and the other one from France. The NATO perspective will be presented by Lieutenant Colonel LUCA, and the Spanish point of view for Major Contreras, and then Colonel Hindermann from the French Air Force will present their national point of view. Please, LUCA.
Ladies and gentlemen, good morning. What is NATO AGS? I'm here to introduce to you, try to give a view from a pure operator perspective. So what is NATO AGS? NATO AGS is the Alliance ground surveillance. We support NATO missions with long-endurance ground surveillance. Just give you some technical aspects of the airframe. The fuselage of the Global Hawk is a modified Type RQ-4 Delta Phoenix remote pilot aircraft. As you can see, it has big dimensions. The length of the aircraft is about 15 meters long, and it's 40 meters wide. Just imagine the wingspan of a regular Boeing 737. The engine is a Rolls-Royce high-bypass turbofan jet engine that produces 8,500 pounds of thrust with a full redundancy in all systems, including the command and control. NATO AGS has the capability of a synthetic aperture radar and ground-moving target indicator. We deliver GISR data to the Alliance. It can cover 100,000 square kilometers in one day. To give you an example, it's the size of Iceland. And it can remain airborne far longer than a manned crewed aircraft, also beyond 30 hours. We fly from the main operating base, Sigonella Air Force Base, Italy. 2 pilots and the 1 sensor operator is the minimum crew required to operate the NATO AGS system in order to fit the ground picture to the NATO chain of command. He can reach the speed of almost 600 kilometers per hour, and we can fly up to flight level 600 with a range of 16,000 kilometers. The aircraft, the NATO AGS Phoenix, is owned by all 30 allies, and all the nations have access to the AGS products. We make the alliance stronger with the near real-time joint ISR data. So again, good morning, ladies and gentlemen. My name is Lieutenant Colonel Luca Gagliardi, and I am serving as a pilot with NATO's AGS force, the remotely piloted aircraft I've just introduced to you. I've served the Italian Air Force for 24 years, flying C-130 Hercules and the NATO AWACS for a total of about 4,000 flying hours with manned aircraft. And lately, the new challenge for me was to join the RPA's world. I am now a line pilot within the NATO AGS flying squadron operating from Sigonella, MOB, Sicily. In the last year, however, I've been also working for the NATO AGS HQ J3 Operation and Planning Cell as the branch head. NATO owns 5 of these remotely piloted high-altitude, long-endurance aircraft. We can reach most of Europe within a matter of hours and stay on station for several hours before returning. It is truly a phenomenal capability. We protect over 1 billion people in our area of responsibility. We have flown in excess of 30 missions since the initial operational capability and a total of 50 missions, including the training sorties. I will now speak on some of the challenges that we face at the operational level. Route planning and diplomatic clearance procedures. We have to draw up bilateral agreements with each country we transit over. This results in a very long lead times, often several months before relevant agreements are made. On the plus side, though, unlike our medium-altitude RPAs, the male, as a high-level long-endurance RPA, we fly between, as I said before, flight level 500 and 600 inside segregated airspace, and due to the requirement for pre-agreements, we are predictable as the mission is pre-planned. Diversion airfields arrangements. Unlike manned, the AGS requires extensive site surveys and special airspace arrangements to stand up our diversion airfields. We mitigate this through the development of mutually agreed approaches and the raising awareness of our contingency modes of operation with nations, civil and military air navigation service providers. Of course, we have to take into account also the routine contingencies. Allies are keen to understand how an RPA will behave in case of an in-flight contingency situation. The NATO AGS Global Hawk is capable to automatically follow a pre-programmed flight plan in order to recover and land safely to any of the pre-approved diversion airfield. Also, lost link procedures are predictable as well. Our pilots are available at all times by traditional landline or equivalent. We have access to the entire pre-planned mission set as well as to the different contingency plans at all times. So, unlike our manned counterparts, a lost link condition does not prevent a two-way communication between ATC and the pilot in command. Let me just conclude with our typical mission flow. In our typical mission, pilots behave the same way a manned pilot deals with ATC, starting from the flight plan submission, where it is clearly indicated that we are RPA. We communicate either with civil and military agencies during takeoff, cruise, and landing. When we reach our area of operations, we are handed over to a military ATC, while always monitoring civil frequencies for situational awareness. AGS are proven as safe and airworthy and are the first RPAs to be issued a military type certificate by the Italian Airworthiness Authority. In my considerable manned experience, I've found RPAs are as reliable or more so than manned, especially as these are brand new airframe at the start of their life. Talking back to the lost link scenario, RPAs are highly predictable due to the intensive pre-planning and availability of the pilot in command. In all cases, it is possible for us to communicate directly to the ATC agencies. As an RPA pilot, I'm able to reach a much higher situational awareness in comparison to my previous manned aircraft experience. I have a clear live picture of ATC and of the current traffic information and awareness of civilian air traffic. We also have redundant means to stay in contact with ATC at all times. I hope I've whetted your appetites. It's a phenomenal capability and an exciting opportunity to fly it and to attend this forum to share my experience. Ladies and gentlemen, thank you for your attention.
Thank you very much, Luca. Grazie mille. Just to one sentence for a concrete sentence. Luca was explaining about NATO, which means horizontal integration. We have been talking about vertical integration. We need vertical integration to meet the higher with the lower. And you have seen that now in the horizontal integration, we need as well every country to contribute to this program. Now I give the floor to Fernando, which is our national Spanish Air Force experience.
Thank you so much, my Colonel, for your introduction. And thank you so much for the invitation to this event. For me, it's the first time that I participate in this kind of event. I will try to do my best with my English. I try to don't punish you so much with my English. And I have a long presentation, but I'm going to fly very fast around the presentation, and I'll give you some ideas about the program. We are going to see the program development that we use in Spain, that we're running now in Spain, the description of the weapon system, some vision type and associated product that we obtained from this aircraft, of this payload, and also that I think is the most important of this conference is the airspace management. Also, I finished with some conclusion. In the program development, the only idea that I want that you take from this picture is that we start with the implementation in 2017. And the first flight took place in Talavera Air Base in early 2020. In the early 2020, and this year, as you know, it had been a very hard year due to the pandemic situation. For that reason, already the experience that we have in this system is only a few months. A few months that we are flying in an operative way with this system in Spain. The next I'm going to describe some aspect about the Predator, that is our aircraft, MQ-9. And okay, I have a video for a land, but this thing is not important. The most important of this is that we operate manually during all the flight. For the land, takeoff, and all the mission, the transit corridor, we operate by hand. We have an automatic mode, automatic hold, speed, and altitude that we can use, also the pre-program mode. But we fly manually almost the most part of the time. Oh, the video. The dimension of this aircraft, as my partner said before, is a big aircraft compared with a light cargo aircraft. It takes a wingspan of 20 meters and a length of 11 meters. And also the crew, for us, the crew is composed by a pilot and a sensor operator. And the pilot in Spain is previously qualified as a pilot in other aircraft. That is my case, that I finished my fighter pilot course in 2003, and after I have the experience in the C-101. I have experience in the F-5 and the Eurofighter aircraft. Then I have experience in the previous military aircraft. Flight characteristics, the most important in this slide, I think, is the normal cruise altitude or the normal operating altitude that we use. We fly almost between flight level 200 and 350. Also, the speed is the maximum is 240, but the cruise speed that we employ is about between 100 and 150 knots. Also, on board we have two radio that we can communicate with the ATC at all time, and we have a telephone link in the ground control station that we can use to call to the tower or whatever we want to call. And also we have the squawk for the mode 3 or 3 Charlie. And also we have for a military application the mode 4 and 5. One characteristic, the flight commander, we have a triple redundant system in the aircraft. Continue the payload that we use in the aircraft is for obtain the product. The main is the MTS, the multi-spectral targeted system, that we have 3 cameras, and I think that the rest of the data is not relevant for this conference. And also we can use the laser not only to mark the target, we can use the laser to guide weapons from other aircraft. I want to remark that the Predator that we use in Spain, we don't carry weapons. This aircraft is only used for intelligence, surveillance, and recognize, but we don't carry weapon on board. The second payload that we use in the aircraft is a synthetic aperture radar that we use to take pictures via radar from the terrain, and also we use in a ground moving target indicator that we use in the ground and over the sea to look ship on the area. Description of the weapon is composed of a ground control station. We use a GDT, a ground data terminal, that we use for a line of sight operation to land and take off the aircraft. During the mission, we use a satellite antenna to connect the aircraft with the satellite. And this is the main component, and with this component, this is the scheme that we use in a normal operation. We are deployed in a base. Normally, the launch and recovery element is deployed in this base, and after the mission crew element take the control of the aircraft and continue with the mission. And after to return to base, the recovery element take the control and land the aircraft. This is the normal scheme. The type of mission, we use we perform two types of mission. One in the exclusive field of the defense for a contribution to intelligence, surveillance, and recognize. I remark again that we don't use a weapon on board. And this is the type, the most common type mission that we fly. By the other hand, the other type of mission is in support of the state action. From now, as I said before, we have only a few months, and it is a vision for the future. We are not now employing this system for the humanitarian crisis and for the support of the state, but we are ready if the state requires us. About the main point, the airspace managed and general route that we use, it is a national regulation that everything applicable to other aircraft is applied for RPAs. In this case, the terminology that we use in the national is the UAS, is a managed. I prefer the RPA, the remotely pilot aircraft. Airspace segregation is the airspace that we have to fly inside this airspace, and this segregated area is prohibited for other aircraft. Also, we always fly with radar assistant inside this type of space, and we have to fill the normal flight plan. I think that the most or the harder part for us is that we need a feasibility and safety study in all the area that we have to fly. In some case, we have to fly in a different area because military aircraft should be ready to operate anywhere and anytime. And this is for us is a problem. And we need a prior coordination to fly. We separate the third area through us to separate with other aircraft outside of the segregated area. And we activate and deactivate this area in a tactical level to avoid to maintain this area segregated for a long time, a long period of time. A special procedure that we have for a lost link mission, if we lost the link with the aircraft, in this case the aircraft starts to the pre-program mode route that is previsible. We know where the aircraft is flying. And also alternative field for us is not applicable. We need to land the aircraft in the base that we have line of sight antenna. Also, we have weather constraint because we are not authorized to fly under freezing conditions. And we have to maintain a separation with thunderstorms about 25 nautical miles. And we are ready to perform an emergency procedure for a forced landing in a depopulated area. If we have an engine fail, we have to look for a depopulated area and try to land in this area in an emergency. This is an example of segregated area that we need to fly an exercise in Spain. As you can see, we have to segregate a big area if we want to participate in a national exercise with the note and publication, the flight plan. That I think is very complex to fly in this situation. And we need to integrate at least the corridor into the general aircraft transit to avoid this segregated area. Conclusion, for us, the most important conclusion is that for me, it is similar to the rest of the crew aircraft. The flight is similar. I'm in contact with the controller, and is similar to previous aircraft that I flew before. And we have a flexibility in deploy, and we have a real-time transmission of the product obtained. And the last, and I think is the most important idea, is that the operation of this system is very limited by the airspace regulation. We are a young unit. We have a short experience in this aircraft, but I think this time it had been enough to feel that we are a little bit stuck in the regulation and in the integration with this type of aircraft into the civilian traffic. And that's all for my presentation.
Thank you, Fernando.
Thank you.
Thank you, Fernando. Now, to finish up with the operational point of view, Colonel Christophe, please, the floor is yours.
Thank you, Arturo. I'm the Colonel Hindermann from the French Air Force. I belong to the State Aviation Authority. I'm the head of the Airspace Division, and I am in charge in France to tackle all the operational requirements with Arpas. What is important in France, we are operating drones since more than 10 years now. All types of drones from the Navy, from the Air Force, from the Army, has to have a military regulation. We have a very nice regulation adapted to our operational requirements. It allows us to cover all the panel of our operational mission. Just for example, in the same area, a normal way, one airpass is one area. We can have several airpass or have mixed flights with manned aircraft flights and airpass in the same area with segregated of activity, not segregation of airspace. Since more than 5 years now, we have made a common analysis with our civil partners from the DSNA, which is the French ANSP. We have also worked with the Space and Air Force because they have the assets, and we have decided in 2019 to elaborate a common roadmap to tackle all the issues with the operational requirements, it's short-term, mid-term, and long-term. And when I say operational requirements, it's not only military requirement. With DSNA, we want to prepare the future, because in the future, I think that we will have very big drones for civilian issues. So we want to prepare the future, and especially the integration in GAT flights. And for this, we are making some trials. Just to cover the short-term requirements, as we have to fly with the regulation, the current regulation in the segregated airspace, we have decided with DSNA to create an airpass network all over France. What we can see is the NAP, which is published in the Aeronautical Information publication in France for the north part and the south France. We have more than 170 small corridors, pieces, roughly 15-20 nautical miles, to cover all the issue and to join all the areas of interest in France, the big cities for air defense issues, the big training areas, etc. These areas can be used with just 6 hours of prior notice to the civilian clause. And when we are using these areas, when the drone flies over the corridor, this corridor is deactivated automatically and can be used against several civilian flows issues. So the impact of the civilian flows is very, very short. If necessary for big defense and security issues like a terrorist attack, etc., we can use this network without notice. It's a special agreement with DSNA, but it's for imperative using. And this Arpas network is daily used for operation, for training, for exercises, for operation. For other issues, on the right part of the screen, you have a map. We have also a network for the hail. It's the big drones like the Aircraft Groblo presented by LUCA. It can be used. It's used 1 or 2 times per month for the moment by the Global Hawk from the USAFI in Europe, and will be used in the future for the AGS drones. And these drones are available. It's corridor at flight level 500. There was no impact on civilian flows. And for this corridor, we have dedicated alternate airfields in France. It's Orange Air Force Base, Luxeuil, and Évreux, and which have been tackled, monitored by the use of experts to see if they are compliant with the drones, and we can use this airfield. It's never had been the case for the moment. It's very nice. But that's good. As you can see in the map I could just, this network is not covering all the country in France. For the military issues, we have to go everywhere in France, liberty of action. So for the future, we are preparing the integration of this small Arpas in GAT flights in non-segregated area. Since January 2017, with our Harfang drone, you see the picture just on the top of the slide, we have made IFR flights. When I say IFR flight, it's an IFR flight plan. It's controlled by civilian ATCOs in non-segregated areas, like a normal manned aircraft. For the beginning, we have worked with approaches in medium altitude. It was phase 1. In phase 2, in December 27, we have made exchanges between military control centers and civilian control centers, always with approach, with a big focus on the failure management, how we tackle with C2 com loss, etc., when there's a problem with the engine, how to tackle all these issues. And now we are in the phase 3. We have some delays due to the COVID situation, but the phase 3.1, which was performed in 2019, with transfer between civilian approach and civilian ACC. We are beginning to go to climb and to go into the higher airspace, flight level 215 to level 220. Last year, we make a trial. It's the map that you can see, the third one. Exchanging between civilian ACCs. We go from Bordeaux ACC to Marseille ACC, make an exchange with the military flight and come back. We have played during this situation some failure engines, some situation that the drone has to avoid the civilian flight, and it was easy, like a manned aircraft. The third phase is the same one with the cross-border flight. It's a trial that we are taking into account with our Spanish partners, this guy. And we expect to make this flight before the end of this year. And you can see on the bottom part the trajectory of the flight, which is scheduled for the moment. We also, during this flight, try to make the validation of the Arpas accommodation study, which was elaborated by the EDA. In the next year, the phase 4 will be to make flights controlled by military CMCC. The military controllers which are embedded in civilian ACC. What we expect to do in the future, we try to do is that the normal flight, the normal transit will be controlled by civilian controllers. If we have a problem, we can pick up this flight by the military controller to manage the failure, manage the problem, and come back to home to make an RTB, return to base, etc. And the next phase will be the second semester in 2022. It's a long-range flight we control for civil approach. There is a deplafoning process in France. The separation between ACC and approaches is, for the moment, flight level 145 and is reaching to flight level 195. So some parts of our drones has to make some steps from one approach to another. It's not the case for the moment at regional level, so we have to test, etc. Our strategic objective of all these trials is just to make, in the behavior of the minds of the people, to consider Airbus flights as aircraft flight. You can manage an Airbus like an aircraft. When you talk to the pilot is respond to you. It just not sit in the aircraft, it's in the cabin. And it's working. And what we want to prevent, especially from the EASA future regulation, is not to have a technical approach. To consider an airspace like a dangerous aircraft and to have lots of technical requirements, Mode S, TCAS, detect and abandon system. It will be the case in 20 years, 15 years, because the technical agreement will be so. But for the 10 next year, with 60 drones in Europe, we are able to fly like a manned aircraft. It's not necessary to have a technical requirement more. And that's my conclusion. For the 2025-2030 framework timeline, we can operate Airbus very easily. It's just an operational procedure, a good cooperation with the DSNA or with your INSP in non-segregated airspace. We can prove it by our trials. And in the further framework from timeline from 2030 to 2035, okay, the regulation can be an accordance with future projects like Euromar, because this kind of asset will have the technical requirement, modest TCAS. And like said, in the future, we will have 250, perhaps more flight drones, because there will be civilian drones inside, like big ones. And so it's necessary in the future for safety issues to have this requirement. But for the 10 next year, it's not necessary, and we can prove it by our trials. Thanks for your attention.
Thank you, Christophe. we have just finished up with this block of operational perspective, where we have seen the integration, vertical integration and horizontal integration explained by NATO, our NATO Italian guy. And then finally, with the importance of the integration, the regulation in every nation to be ready for those Arpas. Any questions? No? Christophe? Can use maybe that
Thank you. Thank you very much for our panelists for this very interesting presentations. We are all aware that one obstacle for the integration of Arpas in the non-segregated airspace is the acceptance. Acceptance by what I'm calling direct stakeholders, such as the other airspace users, air traffic controllers, airports, and indirect stakeholders like the third persons and third parties on the ground. In order to reassure these stakeholders, would you have one message to pass to show, as you explained already in your presentation, but what is your main message illustrating that we can operate such drones today in a safely and security manner? Would you have one main message to pass to reassure our stakeholders that we can operate such Arpas at least in controlled airspace today?
It's a question for all of you.
Okay, if you want, I start with the try quickly, please. For my opinion, I flew before Eurofighter and the F5, and for me, it's the same procedure, and I have the same information in the Predator that in the other aircraft. The difference is that I'm not sitting in the aircraft, but I sit in a cabin, in a crew, in a container, in the ground. But I have all the information around, and the only that I don't have the opportunity to see and avoid other traffic. But in an instrumental condition, I fly in the same condition that in other aircraft.
For my part, I have only one message. An Arpas is an aircraft. An unmanned aircraft or a manned aircraft remains an aircraft. And so we can manage an Arpas like you can manage it. There's no problem. We have, for the moment, short-term technical issues with latency. But it's not proved. We have made the check. The latency with the drone is between 2 and 3 seconds to have a feedback from the message from pilot. It's the same thing for the manned aircraft pilot. It's not more. But we have to manage some communication loss. What will do the drone when there is a communication failure with the C2 process, with the satellite link, but it's easy. Everything is known in advance when you have a problem. The drone is able to make a holding pattern, 1 hour, 2 hour, 3 hours holding pattern to be managed for the failure, to create the situation. If there is a big failure, the drone automatically goes back to home with the same route. The route is known by everybody, by the ATCOs, but it is very easy to manage. Don't be feared with the future with the Arpas. For these big ones, the certified ones.
Yeah, for me as well, my message would be that to me the RPS today are safe. In our case for the Global Hawk is that we received the military type certificate from the Italian Aviation Authority, and it makes the aircraft the same like the other aircraft, and it's reliable. I can easily compare from my previous manned aircraft experience, and this one is same reliability. Even more, we have more redundancy on the systems. And as I mentioned before, also in all the lost link conditions and in all the contingency states, priority in the hierarchy of that, the aircraft is capable to stitch to any point in the route, and according to the type of contingency that is facing to, he will behave automatically in a certain way, and we can monitor. the aircraft itself. And so we are predictable, so we know at any time, at any point, the aircraft where it's going, what it's doing. And also, as I mentioned before, since there's a lot of automation in this on this aircraft, I really have a very high situational awareness of what's going on around me, and I have a clear live picture of the current traffic situation, much more than when I was flying the main aircraft.
Good. Any other question from the audience? Vicente?
I'll break the ice from the audience. It's Vicente de Frutos from European Defence Agency. My question is to all of you, but especially to LUCA. You were saying that you have even better situational awareness, thanks, I imagine, to the sensors that you have on board. So this question is to the three of you, and also paving the way a little bit for Olivia's session later. Could the situational awareness provided, I will do it this way, much better. If you could get the situational awareness or the situational picture from the civilian air traffic injected into your into the cockpit, I mean the ground controlling station, I imagine this would improve still the situational awareness, especially if you don't have on board all the sensors. I see this would even be safer than in manned aviation, because in manned aviation you will not get this. So my question is to you, if you have it first, this connection to the civilian side, so that the picture of the civilian air traffic is injected into the ground control station first, and second, if it is not the case, maybe the technology, and maybe Olivia will tell us later, could improve this.
Yeah, just quick answer your question. Yes, of course, we have integrated situational awareness from the ATC control as well. We use it's still a military software called ICC, but we can see all the traffic, either the military and the civilian traffic. So we are well aware of what's going on. Any other questions?
No more questions? Yes, another one here.
Okay, thank you very much. This is José Ribelles from INTA, the Spanish technical body of the Military Certification and Worthiness Authority. So my question is for all three speakers, please. So I would like to know, when you speak about these alternate airfields or landing outside the field because you have any problem or anything, are you considering any segregation of airspace out of what you have been segregated? So do you have any other coordination outside of your already segregated airspace? Thank you very much.
I can answer from my part. So all the pre-approved airfield, they are already in our database. And as you mentioned, we already have a segregated airspace and the contingency route to fly into that. Of course, we can now discriminate between emergency and weather alternate or other issue. Of course, if we declare an alternate for weather, we follow our pre-planned route into the segregated airspace. If we are in emergency, of course, we squawk 7700, we declare emergency, and we should be treated like all the manned aircraft. So the ATC controller can also tell us the shortest way to fly, giving headings, and he will be responsible to deviate the other traffic. Does this answer your question from my side? Yeah, in case of emergency, we will proceed outside the segregated airspace.
Okay, for my system, it's not contemplating an alternate field. Due to it's not for a segregated area or to have a segregated area. The main problem for my system is that we need a line of sight when we are going to land or take off. because with the KU, the satellite connection, we have a 3-4 second delay in the image, and it's not safety to land in this situation with the KU. Then we use as emergency procedure, and we practice the land in the KU with the satellite connection in the simulator, but it's an emergency procedure, and probably you crash the aircraft.
I can give you the example in France. We have 3 alternate airfields, especially for the global log issues. There's not a problem when you're flying at flight level 500. When you go up to in the lower airspace, we have segregated airspaces for our air bases, TTR, TMAs, restricted area, etc. So between the two, we are in non-segregated because it's an emergency issue. What is important for the alternate airfield is to have a dedicated airfield for this. Because when the drone is landing with BVLOS issues, it will stop on the runway. So the technicians must be checked before, must have a tow bar for these specific drones. The runway, etc., must be in accordance, and the taxiways with this type of big aircraft. The global log is very huge, type. And was it important for the American flights is that the electromagnetic environment must be checked before. It's not necessary. It's dangerous to have a loss of communication due to some local problem in interferences. That's just the case of issue, but it's working very well. I am not sure that for the Reapers that we're using alternate airfields. My deputy is not here. He's shaking the head. Okay, we have no alternate for the Reaper because it's more a local flight for the moment, and you are operating most of the time in Africa.
Thank you, Christophe. Michael wants to say something.
Hello? This is an excellent question, and there's 2 different aspects to it. One, you have the male aspect that's actually being flown full-time by the pilot, but then when you look at Global Hawk and the RQ-4, it's a different problem set. It has many automated features, so depending upon the level of failure for an emergency divert, it requires a great deal of pre-planning. It will not fly to any airfield. It has to be stitched to that airfield. That's all done in the mission support ahead of time. So when you look at a typical flight for the Global Hawk, what you're looking at is every 120 miles, where is a suitable alternate if there's going to be a problem that is not recoverable by the ground stations. If there's, and what that requires is that you need to do advanced site surveys and letters of agreement with every ANSP along the way of the flight route. So when we look at HAIL assets and we look at a much higher level of what it takes to integrate them, there is so much advanced work that needs to be done that you can have confidence that when that aircraft is flying, you know exactly what's going to happen. And it's that confidence with the awareness and the coherence on what those safety standards are, allow us to say that many of these aircraft are as safe or safer than manned aircraft because you know exactly what's going to happen. So thank you.
You're welcome. Any other question? Yep. No, not ready. Go ahead, please.
Good afternoon. Well, my name is Pedro Galotti. I'm from GTT NetCorp. I would like to know from NATO people related, do you have any cooperation or interrelation with another international agencies such as NASA or China agency? I don't know. That's it. Thank you.
Okay, great question. Thank you very much. And where are you from again, sir?
Well, I come from GTT NetCorp. We are based in Houston and Mexico.
Ah, excellent. So through the Aviation Committee, we have partners. Those partners include ICAO, FAA, EASA, IATA, Eurocai, RTCA, EDA, DG Move, and so we have many partners around the world in order to facilitate communications. Through the Aviation Committee, we have a broader network through all of the partners of NATO that are not NATO members, but are different national states. And so whether it's the Middle East, North Africa countries, whether it's AP4, Asia Pacific 4, those are the platforms in which we reach out. On aviation issues, and specifically UAS issues, we are trying to develop the robust communication so that we share as much information as possible in order to support the rules-based international order when it comes to aviation assets.
Okay. If you have more questions, I suggest you can keep it till the end of the presentations, because we are running a little bit faster, a little bit late. And then, and in fact, we are going to change. The next one is going to be, we have finished with the strategical point of view, then we're going to the operational, and now we're going to see how to get all these things that we need on the airplanes to fly Arpas safely and integrated, if possible, in the future. Now I give the floor to Christian from Eurokai. You have changed us because he's a little bit in a hurry. Please, Christian.
Thank you very much. Very interesting discussion so far, and we have seen good examples on the operation, and we see enough examples on the operation on the civilian side, and how there is a common ground. We want to have a non-segregated implementation of our flights into existing airspaces. So that's actually our strategy at Eurocay as well, that we have standards available for all kinds of unmanned aircraft systems, Arpas, in all kinds of airspaces. We have seen the strategic lines at the very beginning that we want to have, or we want to use the synergies between military and the civilian side. And that's key for us, and with EDA and NATO we have partners already where we have very good examples how it can work. I have seen today there is much more potential because you have much more done on the certified side, where we and on the civilian side are a little bit behind at the moment, or their demand is different as you have it on the military side, but I think that's essential for us that we work here together. So what we are seeing at the civilian side, and also taking into account what's already happening on the military side, is a very fast-moving target we try to catch. It's a completely different set of regulations we try to complement with high-quality standards. And don't forget, even if we talk about unmanned systems, and we heard it a couple of times, the expectation is in aviation that we have the same safety level as we are used today for manned aircraft. And there is no difference. And you confirmed that today several times. So we need high-quality standards on top of a regulatory frame. But the regulatory frame has changed. We are moving now to a more performance-based, risk-based, and operation-centric regulatory frame. And that needs more how to comply with this regulation, the how to comply, how we show compliance, acceptable means of compliance. And that's the way we try to provide acceptable means of compliance together with the industry, together with the military, with the input, in order to have a set of AMC available to do that. This is just an outline of the activities, the areas of activities we are having. And you have seen all those words, have heard all those words today already in the different presentations. So nothing new. That's where we're working. And that's not the full picture of drones and standards which are supporting the implementation. We have heard artificial intelligence. Here we have a working group. Very high on the agenda is the security question, cyber security, where we work very closely together. So I think I have used here a couple of examples where we can do, where we are already good today, but we can do much more. We have a partner with EDA, we have a partner with NATO, I think we can partner more. I have heard that you have several levels on a national level. We do it on a regional level to coordinate, but we have global standards which are applicable everywhere in the world. So we try to connect the different worlds. So if you see yourself reflected in one of those topics, we might be your home to develop standards for that. Thank you.
Thank you, Christian. Now, last but not least, let's see what CESAR joint undertaking has to show us on this topic. Thank you very much, Olivia. The floor is yours.
Hello. So, hello everybody. My name is Olivia Nunes. I work for the CESAR joint undertaking. And so I will be talking a little bit about how we are handling this from the R&D perspective. So first of all, briefly to introduce CESAR. I think we're pretty well known at this stage, but CESAR is policy driven. So we are the Single European Sky ATM research. We do the research that supports the master plan, the European ATM master plan. The master plan has been updated several times since this started around 15 years ago. And that has been, you know, amongst other things, for example, to incorporate new needs like this need now to integrate Arpas. And at the same time, it's feeding back into the master plan the results of the research. So it's kind of a two-way. And what we have here is our latest research and innovation agenda. We are in the setup of setting up the next program, what's called CESAR 3. And I just wanted to highlight here that these are our research areas. And actually, Arpas is not in the civil military interoperability, which is the last one, which was we do all the operational air traffic, the IOIT flight plan, the future of the airspace management, but it's actually in the air-ground integration and autonomy. We aim at integrating all Arpas. It just so happens that we are a service. Air traffic control is a service. Air traffic management is a service, and we aim at providing the service to the users. And it's clear to us that it's the first demand is coming from the military. But we actually foresee, so the predictions are this is going to expand. And like we're seeing, we're already operating today to some extent. So I wanted to see just briefly how are Arpas different. We've heard about how they are the same, and there are many things that are the same. They're aircraft, they have a pilot, and the pilot is fully qualified. Many of them have nowadays experience in other aircraft before. Maybe in the future there will be pilots that are only Arpas pilots, but there are some differences. So we already heard about the latency. The latency in the C2, when it's via SATCOM, maybe it doesn't allow always to perform a manual landing. That's important. So maybe radio line of sight is needed there. And that's actually one of the preliminary conclusions of one of our projects, that you would need maybe to have some radio line of sight that would maybe pose a limitation or not on the airfield, because you could actually have the pilot anywhere and have the signal go ground-ground. And that actually adds very little latency and just means that you would need an antenna at the airport, so that would have to be seen. Then we also have the ATC to remote pilot communication latency, which currently are linked because it's relayed via the aircraft, maybe not in the future. I have like a dedicated slide on this. Then one problem we have is the vocabulary. We talk different speech, and we talk in our CESAR, we talk all the time about the FMS, about the selected, the manual mode, and in the Arpas, we see a little bit of a different speech, and it's sometimes a little bit difficult to know if we're talking the same thing or not. It's the same with the military, so CESAR is working towards being able to understand each other more. We're looking for common standards and a common language that will make things a little bit easier for everybody. Then, because of this different speech, sometimes we're not sure if we can implement the same types of clearances or not, whether the Arpas might be a bit slower to implement them or not. So this is all the subject of research. For the most part, it does seem it works and it's the same, but you know, nevertheless, we need to look at it. And maybe just to say the automatic takeoff and landing is an interesting point for the future when maybe the airfields will not be dedicated. So we need to see what impact that has. Does that mean that it needs to be handled a bit differently? You need to provide a landing clearance before, and maybe the go-around cannot be last moment, or is it the same? So that's also a research question. And last, I wanted to talk about the DAA. The DAA is really important, but just for us, we know it's not the basis for separation. So in controlled airspace, air traffic control provides the separation, and that's the way it is. So it is, for us, a safety net. However, we understand that the one thing is the safety net will be necessary in the long term, but at the same time, this aircraft has to be able to fly in non-controlled airspace as well. So the equipment is the same, and we have work in that area as well. But it's right now we're looking at integration into the controlled airspace, and that's where this is a safety net. It's not what's going to be used every day. Then just briefly about the communication. For us, the only option right now in the accommodation period is to have a relay via the aircraft that links the C2 latency to the communication with the remote pilot. But we've already heard from, from the real pilots operating, well, we do have a landline that's there that we can use. And actually, building on this, the way we look at it in the future is that this shouldn't be the backup. This should be the nominal. Yeah, because if I'm on the ground as a controller and you're on the ground as a pilot, why are we relaying via satellite? That's actually adding some latency and some uncertainty that maybe we can get rid of. And this actually would require a connection between the remote pilot to the ATN network, but in an airbase that's kind of easy because you're already connected. So it does seem like a pretty easy thing to do. And I just want to clarify that this doesn't mean that it's going to be handled like it was another ATC facility. No, it's just a pilot, and you're going to be retransmitting everything over the frequency. So from the point of view of the air traffic control frequency, you retransmit and you hear the remote pilot the same as if he was transmitting VHF. Just like nowadays we have frequencies that are paired and you retransmit, so they would be completely integrated. So that's our vision, and we think the military are the best place to start with this new concept. At the same time, it's just pretty clear if there is a loss link, this is already not affecting anymore. There is not a need to actually make any change or contingency, and just. I don't want to read all this. This is our ongoing projects right now. So say very important for us is the accommodation. Accommodation is already happening today nationally, and we are actually looking at building on what's happening today, creating a European solution. Something really important, in case you don't know about CESAR, is our documents are public, our output, and so we aim to disseminate the best practices, consolidate, and get the best from everybody. And that's part of our accommodation solution. And we think that with this, we can move from the current situation, which is, this segregation or smart segregation, like in France, that you have a segregated airspace, but as soon as the Arpas goes, it's freed. So we can go from there to adapted separation, which already allows you to fly GAT and be controlled routinely by civilian air traffic controllers. We think we can do that. We have a project working on it, and that should be finishing in around 2023. And that will produce a data pack, what we in CESAR call our V3 data pack, that will be available for everybody, for all European states and everybody to see. And this will include also a safety case that they're developing, examining whether to what extent the DAA is really essential at this stage. And the impression is that it isn't, because it's very limited numbers. You actually have transponders, so it's not like you're not seeable by the TCAS, so the other aircraft can see you. The idea is you have one aircraft like this only per sector, because we don't have so much demand, so many around, and at the same time, just with one, we know that it increases the workload, but if it's just one, it's just one, okay? So you fly them one by one in a civilian sector. And And to say the cross-border is kind of a case-by-case basis, but if everybody is applying the same, which is what we expect from this European solution, then the cross-border becomes straightforward, yeah? Because we are all doing the same thing. We're using this adaptive separation. So that's what we're aiming for. 2023 would be V3, should be applicable, you know, immediately, basically. Then we have, in Cesar, always in parallel the long term, and that's where we're looking at the integration. So amongst other things, important is that instead of communicating about any change to the contingency via voice, this would be somehow downlinked continuously. There's always a contingency plan, and the contingency plan can be in the flight plan, but sometimes it needs to be updated. For instance, you are given a vector, you're flying on a vector, what's going to happen if you lose the link at that stage? And this will actually, in the accommodation solution, it's included a procedure that the pilot is already saying, well, if I lose the link now, and I'm not talking about a routine link of lost link of 1-2 seconds, I'm talking of a real lost link, which is what we're worried about. Nobody cares about 5 seconds. But in this case, in the integration, this will all be sent, probably using the same kind of standards we use for trajectory intent in civilian aviation, something around the EPP, something similar. And that would be sent probably ground before the link is lost, and maybe from the aircraft after it's lost. So that would be the idea. And apart from that, it would go in one step further. It's not GAT, OAT, but the IOAT that's including this flight plan includes all the transitions in a flexible way. So that's our thinking for integration. At the same time, we have work, obviously, on the DAA, very important. And that includes, at the time, 2 flavors, UDAS and ACAS XU, both two technical solutions for the same problem, if you like. And really important, we have work seeing what's the impact on the human factors, actually, of having this extra information in controlled airspace where you can't really do. And I think I'm running out of, it's a bit long. And then we have work specifically for the TMA. For INVIRCAT, that's longer term as well. So actually thinking of having an Arpas land in maybe between civilian aircraft in a civilian airport like the same. So that's a bit more challenging. And integration in non-controlled airspace. And that's all on my side. Sorry if I went too long. Thank you very much.
Thank you, Olivia. Thank you, Olivia. You mentioned just one word. I was looking into the minds in everyone, accommodation. Nobody wanted to say it, but accommodation and a smart integration is the future, the close future. We have a couple of minutes, 2-3 minutes for questions. We have questions, Nicolas, maybe?
Yes, it's just an answer for the previous questions regarding the management of the emergency procedures in France, and we have, for example, for IQ4, we have for each flight the French part, the civilian part, the DSNA are aware of the flight plan and the planification and the coordination between military agencies that are in charge of the flight, and so they are collocated. So it's easy, and the coordination is based, and every management, in case of emergency, is facilitated. And I want just a precision regarding the Reaper, for example, the mile. If you have, for instance, if you have an engine failure, the aircraft is always pilotable, and with the camera, for example, the pilot with the battery is aware and can manage the flight until the crash, for example, and in a free area from people. And this is important, but in the mind of people that unmanned aircraft are quite dangerous, but not. They have possibilities, and for example, the place of the pilot in case of emergency will be, for example, easier than in a manned aircraft in emergency situation, because he's aware of the aircraft, and it's for him it's easy to manage the emergency situation.
Okay, thank you very much. If there is no more questions, I will give the floor to Christophe in order to close the closing remarks. Christophe and Michael, sorry.
Thank you very much, Arturo. Thank you very much to the other panelists. Thank you, Christophe, and to Expodronica. You heard a lot today, but here's the bottom line. We don't fly ARPAs just to fly ARPAs. We fly them for a reason. We need civil-military cooperation because the military is leading the charge on investigating how to get these ARPAs integrated safely and appropriately into non-segregated airspace. The reason we're doing that is because we have a need. We have a need to do joint intelligence, surveillance, and reconnaissance for security and defense. There is also an economic need to that, as in all of the work that the military is doing to promote that can be utilized by the civil side society in order to promote the effective use of ARPAs within airspace, whether that's in UTM or U-space, or whether that's in high-level airspace. So we have common interests here. And so it is within all of our interests to figure out how to do this. There's plenty of technical requirements that need to happen. There's industrial requirements. There's legislative requirements. But as a community, as a civil-military cooperative community, I have no doubt that we can figure this out over the upcoming years and decades. So thank you very much. And Christophe, over to you.
Thank you very much to all panelists, to Expodronica again, and to complement what Michael just said, particularly regarding civil-military cooperation, collaboration, synergies, obviously is paramount, and I really would like to insist on that. It's essential to be done this cooperation at all levels, meaning at national, EU, global level, but also in all domains, not only in technical domains, but in the regulatory domain, technical domain, standardization, operational domain. This is key. I would like also to come back on what has been raised by Olivia regarding the issue linked to terminology and or taxonomy. I do believe that addressing all drones and the wording is covering many different types of drones is misleading and is making the issue complex. We have seen today that some use cases are already mature, while it's not the case for other use cases. So my main takeaway from today is to perhaps implement a step-by-step approach regarding the integration of drones in the airspace. Another point I would like to raise today and to emphasize is we need to reinforce standardization activities, and related stepwise approach is linked to what I just said. Standardization is also key. Last but not least, I would like also to highlight that we should make the best use of public funds and in a new context of EU funds. This is why we need to collaborate to be sure that we will invest, particularly public funds, in the most efficient manner, and this should be done through collaboration, particularly if we want to highlight some technologies like detect and avoid, artificial intelligence, counter-UAS related technology. We need to do that in a coordinated manner. Finally, I would like also, because today we discussed a lot the big drones, the medium altitude long endurance Arpas and high altitude long endurance Arpas. U-space is also an important topic for the military for safety and security reasons. And I would like to advertise an event. You will find some flyers on your seats This is a public event open to everyone, so do not hesitate to register, and we will address civil collaboration and synergy in the framework of USpace. Many thanks again for your participation, and many thanks to all panelists and to Arturo for